Hello and welcome back to Chemistry from Jay's House. Woohoo! So today we're going to do a little bit of a review of yesterday's class and then we're going to learn one new thing and that'll be it. So this video should be a little bit shorter than yesterday's and slightly less heavy lifting. So yesterday we talked about this. We talked about, well, if you take a water and you add a proton to it, which is actually a hydrogen atom without its electron, right? That's what we're calling that proton. Then you can get hydronium. Woohoo! And if there's a substance out there that can, if there's an unknown substance that has the ability to do that, it can throw a proton at water, then that substance gets the super fun name acid. So if the acid can convince water to take a proton and become hydronium, it gets the name acid. And just to see that quickly, visually, yesterday's class was you take a unknown substance, you throw it in a bunch of water. Woo! Of course, they all had to turn upside down because that's how life works. You throw it in a bunch of water. Look at all that water laying all around. Oh my gosh. And then you wait and you go, okay, water, are you guys still H2O? Because that's what water is. Are you still H2O? And if this substance has extra protons that it's willing to get rid of and force those protons on water, hey, buddy, you want a free proton? Okay, that sounds wonderful. Oh, you're not water anymore. You're now hydronium. Hey, buddy, you want a proton? Sure. You're not water anymore. You're now hydronium. And if it can do that, if it can force water to take an extra proton, it becomes known as an acid. And if it can't force water to take a proton and become hydronium, H3O plus, if it doesn't add an H plus, which is really just one proton, and become hydronium, then you're not an acid. You're just a substance. I don't know what you are, but you ain't an acid. So that's a quick recap of yesterday's class. Now let's get into today's class. Let me get all my cute little printouts out of the way. We'll go that way with them. There we go. So I assigned homework. I hope some of you did it. But we're teenagers and you're not there to yell at us. So of course we didn't. Yeah, that sounds about right. I didn't collect homework. I didn't go over homework, but I know what you guys think. And Jay sure talks a lot. But I hope you yelled, what's the point? Because why not? Let's go to the right. We're still taking notes. This is still acids and bases. Let's go to the right, write the date. This class, I believe, is supposed to happen on the 21st. If not, change the date. Look at your phone or the internet or whatever. And then skip a line, come all the way to the left and write the point. And the point of today's class is, how are acids, which we learned about yesterday, and acidic hydrogens related? That is some terrible handwriting. I apologize. Let me read it again since my chicken scratch scrawl is pretty terrible right now. And that is, how are acids, which we learned about yesterday, and acidic, that's a D. Let's write it in English this time. Acidic hydrogens related. Well, looking at that, I go, well, I already have a definition of that. I took that yesterday. So there's probably only one term, acidic hydrogen. So let's just bang that term out right now. So acidic hydrogen is any hydrogen atom that can, drop down a line, be transferred to water. That's it. So now's a great time for you to hit pause and copy all this down. I expect these to be actually in your notes, even though I'm not there to check them. I expect them to be in your notes and I expect them to be accurate, so just do that. Pause. Unpause. Welcome back. So these are specific hydrogens that are out in the universe. And they get a super fun name. And the reason why is because they actually decide whether something is an acid or not. We're going to get to that soon, but you can only be an acid if you have one of these. So that's kind of the whole thing today is you only get to be an acid. You only get that fun name acid if you have one of these. If you don't have one of these, then you don't get to be an acid. Also, if you don't have one of these, then you're not going to taste sour and you're not going to corrode metal. Remember, that's how we used to define acids is we tasted them and we go, this is kind of sour. It must be acidic, right? And we think of like citric acid. So that'd be like lemon, right? And that's sour. It's the citric acid that makes it sour, and they corrode metal. And it turns out that these are actually what kind of do that. It's these things that make it taste sour, and these things that make it corrode metal, and these things that make it acids. And once acids get rid of them, if they don't have them anymore, then you don't get that name anymore. This is hard to do. Okay. Well, hopefully you have all this. So what does that mean? Well, let's start with just straight water, H2O. So you have a water hanging out, doing its thing. Now, normally, if you take a normal hydrogen atom and try to attach it, well, that's not going to work. And why wouldn't that work? Well, the reason it wouldn't work is because, does this have any charge? Well, let's see. I see a positive charge. I see a negative charge. And I don't know much, but I'm pretty sure that positive 1 plus, and that's the proton, a negative 1 equals no charge. That equals 0. It has no charge. It has no charge. So then how's it going to stick to water? Water's happy. H2O is super happy. In fact, H2O is so incredibly stable and so incredibly happy that I can drink it and not die. In fact, I have to drink it and not die, right? To not die. So water is super content without hydrogen. If hydrogen comes in this form with no charge, then water's like, why are you wasting my time? I don't care about you. But what if it lost that electron? Book. And what if it was just a single proton? Now remember, if it's a single proton, in order to be on the periodic table and to be listed as an element in this universe, it has to be an atom. And it has to be carbon or oxygen or nitrogen or argon or something like that. And every atom that only has one proton gets the fun name hydrogen. Now, if it were hydrogen, if I just say hydrogen, then this is what I'm talking about. I'm talking about one proton with an electron. But this doesn't have an electron. Oh, so it is a hydrogen ion. An ion is anything with a charge. In fact, this has a charge. It's a +1 charge. Because it has one proton, one positive piece, and nothing blocking it. It doesn't have any electrons blocking that positive charge. So now I have a hydrogen atom, and I know it's a hydrogen because it only has one proton, but it has a charge. Aha. Hey, doesn't water have a charge? It has, if I remember correctly, it is a polar molecule, which means that one end is positively charged because hydrogen is showing an OK movie, if you remember this, going back. And oxygen is negatively charged because it's showing an awesome movie. So the electrons spend less time down here, more time up here. And if you have more electrons up here, you get a relative negative charge. And that means that if I have a relative negative charge, and then I have a thing with an actual positive charge, where is it going to fit? Well, it wouldn't fit down here because positive plus positive actually pushes it away. So if it, no, hey, can I, it's like me hanging out with the cool kids in high school. No, thank you. Come on, no. Just kidding. I'm sure I was incredibly cool in high school. Not. But what about here? Oh, look at that. We have a positive charge and a negative charge. We have magnetism happening. And this is going to click on right there at the top. Wait a second. Wait, does that mean that this hydrogen atom just attached to water? I think there's a name for any hydrogen atom that can attach to water. There is a name for any hydrogen atom that can attach to water, and it is called an acidic hydrogen. An acidic hydrogen is any hydrogen that can attach to water. So this lone proton, which we, instead of calling a lone proton, we call a positively charged hydrogen ion, this lone proton will totally click onto water just because of straight magnetism. I'm positive, I'm negative. There you go. And then the water gets changed into H3O+, right? If I turn it upside down, it becomes a little more, right? Click. So that means it has just changed water into hydronium and gets the fun name acid. So it's actually this proton, or acidic hydrogen, that changes water, bink, into hydronium, which means it's this proton that causes acid to be an acid. We'll talk about that more in just a second. So if I have water and two hydrogens show up and try to attach. So there's my water. It's hanging out. And one hydrogen's like, hey, buddy, want to hang out? Water, which is, of course, H2O, says no to this guy because there's no charge. There's no way for it to grab onto water. So, no charge, no attachment, no name. It's simply hydrogen. But then this other hydrogen atom, which doesn't have the electrons, just on its own, it's a lone proton, lost and afraid in the world. That does have a charge. That has a positive 1 charge, which means it will click onto the top of oxygen right there. And because it will attach to water happily, it gets a fun name. It gets the name acidic hydrogen. So an acidic hydrogen is simply a single proton. That's it. If it's a proton with an electron, then it's just hydrogen. It doesn't get a fun name. It's just called hydrogen. It's not going to attach to water because there's no way for it to attach. It doesn't have a charge. There's no way to click it onto water. So it gets no name. It gets no new name is what I should have written. And it's just a hydrogen. But if it's a lone proton and it has a charge, then there is a way to click, attach it to water. Yay! And if it can attach to water, it gets the fun name. It is called an acidic hydrogen. So an acidic hydrogen is literally a single proton. Or, if you want to be kind of nerdy about it, a hydrogen ion, or a hydrogen with a charge, with a positive charge. So this one proton, let's get the rest of this noise out of here. This one proton has 3 super fun names. A single proton out in the world I could call a single proton. Not very imaginative, but very descriptive. I could also say, hey, single proton, I could attach you to water. So you could also be called an acidic hydrogen. Or, hey, proton, if you only have one proton, that makes you a hydrogen atom because every atom with one proton is a hydrogen atom. But you have a charge, so you're a hydrogen ion. So literally, a single proton has 3 different names in chemistry. Yep. A single proton can be a single proton. Or I could call it the same single proton, I could call it a hydrogen ion. Because hydrogens are atoms with one proton. Ding! That looks the same, except it doesn't have an electron. Or a single proton out in the universe, all alone in the world, is also called an acidic hydrogen because it will stick to water because it has a charge. So usually scientists only like one name for everything, but because of history and the way this was figured out, it gets all these fun names. Whoop, there it is. So a single proton is a single proton. It's also a hydrogen ion. It's also considered an acidic hydrogen. And let's figure out this last one. The last thing we want to talk about is why it's considered an acidic hydrogen. Okay, so hopefully you understand that it's a single proton because, well, that's exactly what it is. Hopefully you get it's a hydrogen ion because it's a hydrogen atom without an electron, so it has a positive charge. And now let's just nail down why it's an acidic hydrogen, because it sticks to water. So again, how do I decide if an unknown glop of something is an acid? I know. I'll put it in my mouth and see if it's sour. That's a terrible idea. Okay, I'll put it on metal and wait a really long time and see if it corrodes. That's a much better, safer idea, but also seems a little barbaric. Isn't there a more kind of cool way? Oh, yeah, that's right. I can add it to water and see if it transforms water into hydronium. So I take my junk, I throw it in water, sploosh. Water surrounds it. And I wait, and it doesn't take long. It basically instantly happens. So if my unknown substance is thrown in water and does nothing, then it's not an acid. I don't know the name of it, but it's not an acid. But if it had, let's say, an extra proton, and if that proton could leave the acid, literally leave, bye-bye, see ya, and attach to one of the waters, and it would attach right at the top because the top of water is negative and this proton is positive, and transform into a hydronium ion, then this gets the fun name acid. That's a review of yesterday's class. But what made it an acid? That guy. So if before I add it to water, there is an extra proton, usually stuck out at the very edge, the very end of it. If we were to draw an atomic diagram of it, it would be way out at the end. It would be like a single proton kind of hanging off, or what it really is it's a hydrogen hanging off the end. And then if it will attach to water, then it's an acid. So right now, it is an acid. And the reason it's an acid is because it has this proton, this lone proton, that I know, because of other labs I've run, I know would attach to water if it got near water. But I don't want to get it near water. So right now, it's an acid. And I know it's an acid because it has one of these. It has a lone proton way at the end of it that it's willing to donate to water. So it has this thing called a lone proton, or a hydrogen ion, or an acidic hydrogen. So if it has an acidic hydrogen, it is an acid. So now I sploosh, throw it into water. The acidic hydrogen leaves. It attaches, we'll do it over on this side now, to this guy. H2O is now 1, 2, 3 hydrogens, positive charge. It becomes H3O plus. Wait, this acid, where's all of its acidic hydrogens? It donated it. This acid no longer has an acidic hydrogen. Oh no, that means it actually loses its name. It's no longer an acid. And why is it not an acid? Well, do you see any protons that would transfer to water? I don't. So do you see any acidic hydrogens? I don't. So the moment it reacted, back when it had the proton attached, it was an acid. But the moment it lost that proton, it lost its name. You are only an acid if you have an acidic hydrogen. The moment you lose that acidic hydrogen, you lose the name, and now you're just a substance. So, quick recap. If you don't have an acidic hydrogen, I don't know what you are, but you're not an acid. If you do have an acidic hydrogen, then you are an acid. Ding! So I want to answer the point and then say one quick thing, and that'll be this video. So what was the point? The point, if I remember, and hopefully you are yelling at the monitor, how are acids and acidic hydrogens related? And the answer is if you have an acidic hydrogen, then you're an acid. Conversely, and that's all you need to write in your notes, but I'll write, and conversely, if you don't have an acidic hydrogen, you aren't an acid. So the only difference between this substance and this substance is that this one has an acidic hydrogen, so it's an acid. This substance may have had one and given it away, but since it doesn't have it anymore, it's no longer an acid. So the moment it gives its acidic hydrogen away, take that, whatever substance you are, oh, it loses its name. Oh, remember the good old days when I had my acidic hydrogen and I was an acid? Yeah, those were the good old days. Bam. So I will see you in a pre-recorded fashion tomorrow. Have a good one.